example that we are going to start with is possibly one of the most important application areas for linear models, especially in India, namely agricultural statistics. Now suppose we have different varieties of the same crop and we want to know which variety is good, so which variety grows more, so provides more yield. Now how would you go about testing? So how would you go about checking that if this variety is good or that variety is good, you want to estimate which produces more average yield and things like that. Then obviously the very first thing that you will do is to start with certain plots, and these plots should preferably be as similar to each other as possible. The same old story of being as close to possible to the IIT, so that all differences among these plots may be swept under the rug of the random errors. So here I have shown you 8 different plots which are more or less identical, and we want to show the different varieties in these different plots. Now such agricultural experiments are carried out regularly. For example, I had once visited Vishwanath Chariali, which is the agricultural department of the Guwahati University in Assam, and they have these little plots, this very tiny little plots, something like 2 meter by 2 meter plots, and there are lots of them, and in different plots they have shown different types of varieties and crops. There were spice herbs from Kerala, there were some kind of plants from Malaysia and all those places. So what you do is that once you are given these 8 plots, you pick, so we have got say 3 varieties, then we pick any random 3 plots out of these. Why did I pick 3? Because 8 divided by 3 will be approximately equal to 3. So I pick any 3 random plots and so the first variety there, so 1, 1, 1. I did this randomly because if by any chance there is some differences, I want to give each variety equal chance. So I just pick 3 of these 8 plots randomly, simple random sampling without replacement, and I sowed. Then out of the remaining, how many? Remaining 5, I picked again some 3, and there I sowed the second variety, and the remaining 2 I am forced to sow the third variety. So I have got these 8 plots and I have this thing. Then I continue this thing for about say 1 season, and then drip our harvest and I measure the yield. We want to analyze these yields in order to understand the effects of the different varieties. So let's try to understand this in terms of our familiar box diagram, pretty trivial in this case. So it will take this form. So I have got this black box, which is in this case the plots, and I have got one input, that is the variety, and I have got one output, that is this thing, the yield. So I have the variety and yield, and of course I have the inevitable random error all the time. Now observe that I have got 2 arrows other than the random input arrow, so I have got 2 arrows, and hence you can easily understand that we are going to have 2 columns in our data set. And so since we have 2 columns, we are going to see something like this. We have got all these things, these are the varieties. So I have got how many rows? 8 rows, and they are 1, 2, 2, 3, 3, 2, 1, 1. I have just collected the data just row wise, so I have this ordering, and these are the yields in some units. So I have got these 8 rows, 2 columns, because I have got 2 arrows. Okay, so now we have to see how exactly we express this in terms of a mathematical model.